Hello everybody, welcome to the next video. This video is titled Writing Names for Any Compound. You've done a lot of practice with learning how to write the names for various compounds, but each of those compounds has kind of been in a category. Those categories being ionic compounds, acids, and molecular compounds. And while you were learning and practicing, you were always made aware of what category compound you were looking at. Therefore, it was easy to apply the rules. However, as a good chemist, what you want to be able to do is look at any formula for any compound and determine for yourselves what category it belongs to and then how to write its name. And so that's what this video is meant to show you. Doing that really requires two steps. First, you want to look at a compound and determine what type of compound it is, or in other words, what category it belongs to, ionic, acid, or molecular compound. And then you want to apply the appropriate rules. To help you get good at doing this, I've included this here flowchart called the Naming Compounds Flowchart. What you do is you look at a formula for a compound and you let this flowchart guide you. This flowchart has a lot on it, but it does not have everything that you need. I tried to squeeze in quite a bit here, but not everything can fit. So in order to practice this, you will have to rely on your notes or on some of your previous materials and practice pages and whatnot. So let's do some examples and see how this flowchart works, okay? So here we have a nice formula, BaF2. Now you as a chemist, you don't want to call this BaF2. You'd want to speak the language of the chemists. You'd want to be able to walk the walk and talk the talk. So that's why being able to come up with the names is a great thing. So let's begin right here where it says start here. Does this formula begin with H? I don't think so. So let's go over there. Does it begin with a metal or ammonium? Well, I think Ba is a metal. I don't know. Let's go to the periodic table. Barium, Ba, there you are. Yes, you are definitely on the metal side of the periodic table. So that's a yes. So we're going to use the metal name and we'll change the non-metal to IDE, and we will not include prefixes. Now there's an additional question here. Is that a multivalent metal? Yes or no? So that's where this other chart of multivalent metals comes in. And we can see that barium has but one possible charge of +2. Therefore, not multivalent. We don't use a Roman numeral. So this one is fairly simple. Barium, we're going to give it its name, barium. And fluorine is the nonmetal. We'll change it to the IDE ending, fluoride. Wait, should we call it difluoride? No. When metals are involved, we do not use the prefixes like di and tri and mono and that other stuff. And so there you are, barium fluoride. Hey, a little side note here. You get extra brownie points if you spell fluoride correctly. It's spelled F-L-U-O. Not too many words are U-O. We have a lot that are O-U, but this one is U-O. Next example. Here's a wonderful compound, H2SO3. Gee, what name should that get? Well, let's consult the flowchart. Does it begin with H? Yes. Is there a polyatomic ion? I see a polyatomic ion. I've been studying chemistry and I'm getting good at recognizing them. If I wanted to double check, I could. Right, here's the SO3. There you are. There you are. SO3 is there. All right, so yes, there's a polyatomic ion. So we're going to go with, we're not going to use hydro at the beginning. We're simply going to realize that H becomes ic acid and IT becomes us acid. So what is the name of this polyatomic ion? That is sulfite. So sulfite, ITE becomes OUS. And so, well, sulfur is the funny one. It keeps the name So this would be sulfurous acid. And there you are. And again, it's because this thing here is sulfite. It becomes us. It and us correspond. And there you go, sulfurous acid. It's not sulfurious acid. It's not angry. It's sulfurous. All right, next compound, SiI4. What the heck is that? Well, let's see. Does it begin with an H? Nope. Does it begin with a metal or ammonium? Well, let's see. Silicon. Not sure about that one. Is silicon a metal? There you are, silicon. No, you're on that staircase. You're a metalloid. So no, you're not a metal. If you were a metal, we wouldn't be calling you a metalloid. Now, would we? Okay. So it's all no. So we use the prefix system. How does that work? We use prefixes to tell us how many to represent the subscripts. Silicon has an invisible subscript of 1, so we'll just write silicon. Hey, wait a second. What about mono? Special rule. The first element in one of these compounds, if there is only one of them, does not get mono. It just gets its own name to represent one of them, much like carbon dioxide has 1 carbon. Okay, I is iodine, and there's 4 of them. What's the prefix for 4? Oh, that's tetra. So we would write tetra iodide. And there you go. It doesn't really say it in the flow chart, but when we use the prefix system, the nonmetal at the end still gets the IDE ending. That's kind of a classic ending for the compound names all throughout chemistry. And there you go, silicon tetraiodide. Next example. Here we go. HGO. Hey, isn't that on television? There wasn't Game of Thrones on HGO? No, that was HBO. Different. Sorry. HGO. Does this begin with H? Well, it kind of does, but it's really not H as in hydrogen. It's Hg as in mercury. So this is no. Okay? Does it begin with a metal? Hg, mercury? That's a liquid. But I don't know. Is that a metal? Get out of there. Oh, there it is. Hg. Yes, it's definitely on the metal side of the periodic table. So that's a metal. Oh, all right. So we're going to use the metal name, and we'll change the non-metal ending to "ide," and we will not use prefixes. One other question. Multivalent or not? All right, well, let's find out. Let's go to the multivalent metals chart. Ooh, mercury, where are you? Oh, look. You're multivalent. You could either be a +1 or a +2. So what does that mean? Yes, multivalent. We're going to need a Roman numeral to represent its charge. So let's go with mercury. Is just mercury. Oxygen, we'll change that to the IDE ending, oxide. And then we'll use a little bit of logic and reasoning. The oxygen ions are -2 charge. We know that from the periodic table. Oxygen's in the -2 column. Therefore, in order to balance out and equal 0, the mercury must be +2. So mercury 2 oxide is the name of this compound. Wonderful. Last example, and then you get to practice. HBr. Does it begin with hydrogen? H. Yes, there it is, right there. Okay, is there a polyatomic ion? I don't see one. Okay, so that's a no. So this is going to be hydroblankic acid. What goes in that blank? The non-metal name with the ending changed to ic. So this one is not bromine, hydrobromic acid. And that's that. So there you go, folks. There's how you can use that flow chart to determine the names of compounds. When practicing, make sure you keep this flow chart nearby and make sure you look at it every time for every single example. Eventually, you won't have to look at it. That means you've learned it and you can apply the rules kind of naturally on your own, and you don't need it anymore. And that's the goal. That's where you want to be. That is all for now. I say to all hand, which means have a nice day. All right, stop button. Where are you? Pow. Come on. There we go. Bye.